All right, welcome to Calculus Chapter 2, Day 1. Today we're going to talk about derivatives. So we just finished going through what is a limit and why limits are important. So that's the big first thing of calculus. The next big thing is derivatives. There's three main things in calculus: limits, derivatives, and integrals. We are in the second part. So if I go too fast or you don't have enough time to write down this definition, go ahead and feel free to pause the video. As you can see, there are two different hidden parts. Both of them are important. I'm going to give it to you one at a time, so that way you have time to digest both. The first thing that's important today is the definition of the derivative of a function. So that is if f is defined on an open interval containing some value c. Remember, we used that c when we were talking about limits. And if the limit does exist, which means that we have to be able to find it from the left and the right, then the line passing through that point of c, and that y value, wherever it is, so f of c, has some slope m, and that is going to be the slope of the tangent line to whatever my graph of the f is at that point c of f. So again, go ahead and pause this video if you haven't had a chance to write it down. So what this is saying is, at that point c comma c f of c, or say y because that's the y value, that point is then considered the slope of the tangent line. And in order to find the slope of that tangent line, we're going to use this lovely formula. So again, welcome back if you've already paused it, and then pause it again to go ahead and write down this little formula. So we're going to be looking for the limit as h approaches 0 of my f of x plus h minus my f of x, all divided by h. And when we simplify this down, that simplified will be that slope. Okay, first one. So I just told you that my, hold on one second, I'm trying to get my computer screen from shaking. I just told you that the formula is the limit as h, I'm sorry, I'm so used to saying x, as h approaches 0 of f of x plus h minus f of x all over h will give me some value. And that value will be considered the slope. So when I'm looking at this first part of it, it's saying f of x plus h. So I'm going to find the limit now as h approaches 0 of f of x plus h, meaning I'm going to plug in this whole thing for x. So instead of 2x, I'm going to have 2 times x plus h minus 3 minus the actual function of 2x minus 3. That whole big giant kit and caboodle divided by h. Now, if you recall your limits rules from last unit, you would know that we cannot just go ahead and plug in 0 because of the fact that we can't plug in 0 because it'll make it undefined. So what we're doing is we're going to simplify this in order to find this derivative, or this limit of this derivative. Okay, so I'm going to go ahead and multiply that 2 in now. So 2 times x gives me 2x. 2 times h gives me 2h minus 3. I have to distribute this negative sign through, so I have minus 2x plus 3 all over h. Okay, now what we're going to do is look for stuff that cancels out. Well, I have positive 2x and minus 2x. So those cancel, those give me 0. Then I have minus 3 and plus 3. Those will give me 0. So I'm left with 2h over h over h cancels out. So my slope in this case is 2. Now, you're probably thinking, well, this was equal, if you go back and scroll up for a second. If you look at your original function, this is already written in my slope-intercept form, correct? Y equals mx plus b. So you could have looked ahead and said, well, oh, it's obviously 2 because my slope is the value with my x. Well, what happens in this next example where there's no just solid x? I can't easily just see what that slope will be, so this is why we have to use this formula. This is why it helps us figure out what slope is. Okay, so again, that formula was the limit as a x, I'm going to keep doing that, I'm sorry, as h approaches 0 of f of x plus h minus f of x, all divided by h. So first I have x plus h quantity squared minus 1, because that's that first part, minus the function, so minus x squared minus 1. Now remember all of that in parentheses, because I'm going to distribute that negative sign through later, all divided by h. Now you can write a little thing over here. Oops. You can write another little group of parentheses, because you know we're going to have to square this out. X times, we're going to switch colors. X times x gives me x squared. X times h gives me x times h, which is xh. I'm going to get another one of those, which will give me plus 2xh, and then h times h, which gives me h squared. Minus that big 1, minus x squared, plus 1, all over h. Let's look for some stuff to cancel. My x squared and my negative x squared cancel out. My negative 1 and my positive 1 cancel out. So now I'm left with 2xh plus h squared all over h. Well, I still can't plug in that 0 because I have h on the bottom. That's not going to make it, that's going to make it undefined. Can't do that. So I notice I have an h term in both pieces on top. So what I'm going to do is I'm going to factor an h out of the top, which gives me 2x plus h times h. Remember that h is still on the bottom. Now I can cancel those factors of h left, excuse me, that I have. So now I'm left with 2x plus h. Now I can plug in 0, so 2x plus 0. So the slope here is 2x. So yes, that first example with that polynomial, you were like, oh, well, it's easily just going to be 4. But we need to practice using our nice little formula in order to make sure we get the same slope, so we get used to practicing it. Because again, we're going to start using equations that are bigger than just normal simple lines. We're going to have the parabolas, we're going to have the cubic functions, we're going to have the fourth functions, we're going to have functions to the 10th. So we need to get used to using this nice little limit, so that way we can find all those slopes. So if you think logically, my answer should be, think it out loud, think it in your head, I'm not going to say it. We're going to prove it. So again, the limits as h approaches 0 of f of x plus h minus f of x over h. F of x plus h means I have 4 times x plus h minus 5 minus the function, so minus parenthesis 4x minus 5, all divided by h. I get 4x plus 4h minus 5 minus 4x plus 5, all divided by h. My 4x and my 4x cancel out. My minus 5 and my plus 5 cancel out. So I'm left with 4h over h. H over 8 cancels, and I'm left with 4. Which, again, if you're used to your slope-intercept form, you should have already instantly seen that my slope is going to be 4. This way, we can double check ourselves with our when we use our formula. All right, last example. Now, again, I can't just easily look at my formula, or my equation, excuse me, to tell you what the slope is. So we're going to use that limit as h approaches 0 of f of x plus h minus f of x all over h. This first part is going to be the square roots of x plus h minus the square root of x, that whole thing divided by h. Now, if you notice, I don't have stuff that's going to cancel out yet. I have square roots, and nothing's nice and easily canceling out. So if you recall from doing my limit stuff, when we got to this point, what did we do? We are going to multiply by the conjugate of the top. So we're going to multiply by the square root of x plus h plus the square root of x to both the top and the bottom. All right, well, when we agree that we get on top, we just have to multiply the first and the last. When I multiply the first, I need a different color. Here we go. When we multiply by the first, we know that we're going to have that square root squared. Square root and square cancel each other out, so I'm left with x plus h. Negative times positive gives me negative. Square root times square root again gives me positive, because there's 2 of them. And then on the bottom, we're just going to stick everything together. We're not going to multiply it out. It makes our lives easier by not actually multiplying. All right, well, then we see that we have on top x plus x minus x, which leaves me with just h. Now I have h over h, which, woohoo, those cancel. So I'm left with 1 over the square root of x plus h plus the square root of x. Plug in 0. When I plug in 0 for h, I get x plus 0, which just gives me x. So I have 1 over the square root of x plus the square root of x, which is saying I have 1 over 2 root x. Hey, I don't like having roots in the bottom, so I'm going to multiply both the top and the bottom by square root of x. So on top, that gives me the square root of x. On bottom, I get 2x. I'm going to leave this as my answer. So the whole point today was finding that slope value using that nice little formula that we got on slide 1. All right, that's all I got for you. See you tomorrow.